Welcome to the Building Web3 podcast. Today, we're diving into the $100 billion AI cloud computing market. Discover how Nosana leverages consumer GPUs to decentralize AI and make it more accessible for everyone involved. Remember, nothing stated here is financial advice. Welcome to the Building Web3 podcast. Today I have Jesse, the co-founder at Nosana. Jesse, before we get too deep into Nosana, could you give us a brief introduction into your background and what led you to the Web3 space?
Of course. Happy to be here, Jax. So, yeah, I've been in the space for quite a while. So like how I got there, we have to go quite a bit back. I've been like into technology since I was very young. Like in the teenage years, I would do a lot of programming. I remember when I was like around 18 years old, I did a year in university studying mathematics. And a year later, I switched to artificial intelligence because I wanted to do a bit more applied research, like not so abstract. And back then, the space was very different. Like AI back then was just at the beginning of neural networks becoming efficient in doing like image recognition. So like it's kind of a crazy progress we've seen since then. So back then when I started studying, a neural network could just about tell the difference between a cat and a dog and like a house and a horse. Like that was the level it was operating at. But I really liked the space back then. And it's at the same time actually that I got into cryptocurrency. So I remember like when Bitcoin just came out, from a technical like element, I was extremely attracted to Bitcoin and later on Ethereum as well, mainly because of the open source and like open contribution like element to it. But I'm a massive fan of open source and freedom technology. So Bitcoin naturally was very interesting to me. I've been following it very closely over like the 7-8 years that I was studying AI. And at the end of my studies, I really wanted to work in that space. So I wanted to combine artificial intelligence and blockchain technology. And I founded a company back then called Effect AI, which was basically a decentralized AI platform for creating data sets to train these algorithms. So basically to train neural networks to do certain, like to create agents. And again, this was around maybe 10 years ago, 9 or 10 years ago. So it was still a very different space in the AI and also in the Web3 side of things. And then over the years, I've been working in a lot of Web3 ecosystems. Like I've done a lot of work on N-Chain, and on Neo, and on EOS, Ethereum, Solana. Like I've worked in a lot of different ecosystems. I've worked on programming DAOs and creating staking systems and AI marketplaces. So I've been very active over the years as an entrepreneur in all these ecosystems. And around 2.5 years ago, I really felt like we needed to work on the infrastructure side of Web3, so making the computers, the physical hardware that's running all of this to make that more decentralized as well, and that's basically where Nosana came out of, and that was around 2.5 years ago. But that gives you sort of the background where I come from.
Yeah, absolutely. And let's talk a little bit about Nosana and what is the mission? What's the overall goal of the company?
So Nosana is making AI inference more accessible and affordable for everyone. What that means is like AI inference is basically using artificial intelligence and running AI models. So when you interact with ChatGPT, you're running AI inference all the time, back and forth. And at the moment, there is a big shortage of the hardware required to do this. So like if you look at how AI works, you have to run it on a computer. And this computer needs to have a specific chip called a GPU. And since the AI boom, since ChatGPT came out, we've seen so many new models coming out. And since that moment, there's been this exponential growth of people running and companies wanting to run AI. And that's why this hardware, the GPUs, have become extremely scarce. And what Nosana is trying to do is making GPUs affordable and accessible for everyone. So what we're seeing today is that there's around 10 companies that own the majority of GPU hardware. These are like the big cloud providers. And they have all the power in hands to develop and use artificial intelligence, which it's amazing because they're making amazing products, but it's also dangerous because there's a whole lot of people and companies that don't get access to building and using AI. So Nosana's mission is to overcome that, and we make GPUs like accessible to even smaller companies, startups, hackers, data scientists, solo developers, research groups, students. We want to make everyone capable of running artificial intelligence. And the way we do that is that we enable consumer hardware to be used for it. So GPUs are not only available in clouds, gamer PCs, in some other hardware like mining racks that people might have at home. There's a lot of this sleeping latent hardware around the world, and that's what we're using for running AI. So that's the Nosana's.
And why are GPUs specifically so important for running AI models?
So what a GPU does, it's like I said, it's a very specific chip in a computer, and it can run AI inferences very, very quickly. If you look at what an AI is, it's basically just a whole bunch of numbers, like a lot of billions and billions of numbers. And when you ask it a question, like if we imagine it being a chatbot, you have all these numbers get multiplied and added and multiplied and added. Until an answer comes out, and which is again a bunch of numbers representing words. GPUs are designed to do that really, really fast. And one of the cool things that like we got lucky with, I think, as an open source ecosystem, but in general, as even as humanity, we got lucky with, is that this special hardware to run AI is becoming one of the most valuable resources on Earth, because AI is becoming so valuable. Like, I think that's becoming really clear that artificial intelligence is becoming this extremely important for society technology. And to use it, you need this special hardware, which is, of course, like owning that hardware gives you a power position. But we got sort of lucky that gamers that have like the majority of the GPU industry revolves around gamers, like anyone that has an NVIDIA 4090 in their gaming rig. There's a lot of people out there that they are able to run AI. And that's sort of a coincidence, maybe, that gamer GPUs are very good at running AI. Like just the characteristics why they were built. They have like high memory bandwidth. They have not so much memory, but like they have certain elements there, like quick calculations, and they're extremely good at running AI algorithms. So that's the big bright side. And if we manage to really put a network together that enables people to access these gamer GPUs, we were able to create like a super cloud bigger than anything available, like in AWS or Google, for AI inference.
And let's talk a little bit about what it takes to coordinate these latent GPUs. Like, how are you guys going about creating this kind of DeepIn infrastructure, and DeepIn being decentralized financial infrastructure for people that aren't familiar?
Yeah, that's a great question, because this is the beauty of DeepIn. I think this is an excellent example of, and a really important example of why DeepIn is necessary and why it's important. DeepIn is technology that allows us to connect physical devices around the world and create a network out of it that is basically able to capture anyone with an internet connection can connect their device. You get that huge network effect that allows us to really scale this network to large sizes. And it contains all this technology. Like DeepIn is able to do incentives and payments. So even if you have your hardware connected, if you would have to pay people by bank for their hardware, and like there has to be all this, like there's all these like complications if you're doing this in a centralized way to connect hardware. Well, in DeepIn, we can do micropayments, and there can be reputation scores and staking and a whole tokenomic system that allows us to make sure that everyone connecting the hardware gets rewarded in the right way, and that no one is able to cheat the system, or like if they would try to cheat the system, that gets detected. So those are the elements of DeepIn that allow us to use these consumer devices. And how we do it is, that gets technical very quickly, but on the high level, we use the Solana blockchain. We have a bunch of smart contracts there. We have a staking system there. The Nosana token is there that's used to compensate people for providing their GPU power. And these smart contracts are basically interacting in sort of in an ecosystem way, where anyone can join with their GPU, and where if I'm an AI researcher or a developer that wants to run some models on a GPU, I can just go to the Nosana network and see what's available in the inventory and basically run the models that I want.
Absolutely. So let's say, I have some latent GPUs running around. We'll call this the life of a transaction, the life of working with Nosana network. So I have some latent GPUs. I log on to the website and I say, hey, I want to commit X amount of resources to the Nosana network, and for which, if people use it, I'll be rewarded. How does it walk us through how it kind of works from the retail user perspective? And then let's also talk about from the consumer perspective.
Of course, yeah. So as a GPU owner, you can go to Nosana right now. Like you can we have a lot of GPUs on the network, so there's kind of a waiting list. But anyone with a GPU can basically go now on the waiting list, and they will be added as soon as there's space for them in the network. But how it would work once you're connected to the network, you just open the Nosana software. It's like our container node, it's called. You can just run that in a little script. It will open up. It will reserve the space on your GPU. It will run a few benchmarks to see how performant you are. And then it will basically make you available on the marketplace. And from that moment on, you don't have to do much anymore. You just leave it on. And from time to time, Nosana will start running some AI models on your GPU. And every time that happens, you get paid. There's a few more complicating parts where you have to stake some tokens in order to become a GPU provider. That's just in case that you try to cheat the system. Maybe, when malicious users might say they have an H100 GPU, which is a massive, expensive GPU, while they actually run it on a smaller one, like a 4090. This kind of things happen. So that's why we have a staking system where if you were lying about your performance and then later on you get caught, you would get slashed and lose some of your stake. And that's the security mechanism in place. It's easy as that from a compute provider. As a client, like as an end user, so if I'm a researcher that wants to run some AI models, popular now are mainly the LLMs, like Facebook just released, or Meta, they just released the 3.1 Llama model. It's like the state-of-the-art open source, open weight model that people can use. And how this works is that you can download the CLI of Nosana. It's like it gets a bit technical, as people that we're targeting are sort of in the data science AI space. But they can just run Nosana post Llama 3.1, and they put basically some extra data into the CLI, and they would get back an endpoint that they can use to talk with Llama 3.1. Just like it's like they're chatting with ChatGPT, you can talk to an open source model powered by Nosana. So it means that this model will run somewhere on Earth in someone's home on a GPU, which is pretty cool. You would pay in NOS tokens, so you would have to have some balance on your wallet, and as long as you're using these models, you will be draining that wallet every second in order to pay for the resources. That's the bit more in-depth way it works.
Now, one question I'm sure people will come up with is, hey, if I am using GPUs out of an AWS server farm or Google Cloud, there's an uptime expectation because probably standardized hardware, all kinds of things. But if I'm running my model off somebody's, Xbox in their home or some kind of latent GPUs that they have, what's the guarantees in terms of service reliability? Is there essentially a system where if the model fails on somebody's computer, it essentially goes over to another computer? Talk through some of the reliability concerns people might have with these decentralized networks.
Yeah, this is a great topic, actually. What we're doing now at Nosana is we're building that base layer, and it doesn't have all those features yet, and all those it doesn't have the same reliability yet as cloud providers. So we are working towards that. And how it currently goes is what we request from compute providers when they become available on the market, they have to commit for at least 2 hours to be online. So basically, if you get assigned a job, you were supposed to be online at least for a maximum of 2 hours. But if the job runs for over 2 hours, that's basically when the node can decide to go offline without getting slashed, without getting punished. And from a client perspective, there's a lot of jobs that need to run indefinitely, or that you want to run maybe for 48 or 96, or maybe you want to have an endpoint for a month. And we are developing an ecosystem. It's also largely community driven, but it's an ecosystem where people can build things on top. So we're working on a load balancer that sits on top of our nodes that basically will automatically rotate to a new node after the job is about to expire. So if there's you're nearing that 2 hour limit, it would basically open up another endpoint and then load balance to that new endpoint. And there's various other ways we're working on creating these layers on top that give the stability of a normal network, while because our nodes are inherently a little bit unstable, right? You have people, their homes are the connectivity you have at home is a factor at play, and so there's a lot of things we need to consider, and this this stabilization goes in layers. But in the core layer, we require people to be 2 hours online with stable internet. And this is something we benchmark. And if you cannot reach those numbers, we can benchmark, we detect it, and you would get filtered out and then potentially even slashed, but that doesn't happen too often. And then, so from that building block of 2 hours stable inference time, we're building, a whole like convenience network on top where you do have that cloud type of reliability. And we're pretty sure we're going to get there pretty soon as well. But of course, growth is something that's hard to, you have to take small steps to ensure you can get there. And that's what we're doing as well.
Yeah, let's talk a little bit about, like, some people might be like, hey, I use ChatGPT. What is the importance of even having decentralized AI or decentralized infrastructure in the first place? I might be confused as to why we need this.
Yeah, that's also, I think, a very interesting topic to talk about. It's a very hot topic right now, as Mark Zuckerberg just has done a bunch of podcasts and wrote a big blog post around the importance of open source. He's mainly referring to open weights, LLMs, but it basically means that these models are open for anyone to use and also to adjust and modify, which is extremely important. Compared to ChatGPT by OpenAI, this is a model that's closed and no one is able to access their data, access those weights, or make adjustments. So there's a massive amount of power within OpenAI's hands as they, first of all, gain all that incoming data from people using their services that they will be able to resell or use to train their models. But on top of that, no one can really use that AI in their applications on very creative or cool ways because they will, first of all, rely on ChatGPT. And second of all, they just don't not have access to all the little knobs and things that you can change in models. If you look at what's being done now on the open source side of AI, already since Llama came out, it's just an insane amount of really cool innovations that are taking place. People are fine-tuning models in all kinds of smart ways. The applications on like different languages. What is being done with Llama is just so creative and cool that I think, like, I dare to say that it's kind of becoming really clear that open source AI is the only way forward for society to be able to rely on these technologies, because it will allow you to, first of all, not fully depend on OpenAI. It will also allow you to make cultural and diverse models that are making models non-biased and culturally diverse is something I think that's not possible if you have one company building it. You need to have communities building their own models and making adjustments. And especially when you're talking about LLMs that have so much cultural data in them that might, something might be racist in a certain culture while it's not in another culture. And this needs to all be sort of, people need to be able to build their own models that reflect their values. I think it's extremely important. And now we're talking about only the models themselves, which are basically the software layer. On the hardware layer, it is also important to get this open source and open for similar reasons, to get an open ecosystem. And that is what Web3 and Deepin is doing. And what Nosana is specifically doing is making GPUs also open and accessible for everyone. Because even Llama is trained by a really big company that has a lot of GPUs that allowed them to create Llama. And the end result, they're publishing it. But the resources they had available to build that model are not available to everyone. So they still have sort of a power position there. It's less because the end result is open and people can make changes and use it in different ways. But people aren't really able to replicate this and maybe go in a drastically different direction from the start. And that's what you will be able to achieve with open networks, we believe.
Yeah, I always think it's funny when, Mark Zuckerberg, obviously, Facebook, Meta, they released Llama. There used to be a Google playbook back in the days. Like, if you're essentially behind in the race, you will open source. So if you look at, like, Google released Kubernetes, which was the internal version, or the open source version of Borg, because they wanted people to be able to drift away from Google or Amazon, AWS cloud, and Azure. So it's easy to containerize and move things. So I'm always a little skeptical when I'm like, oh, is this why it's open source? But I guess all motivations aside, it's good for the ecosystem.
Yeah, that's true. That's a good observation. I think it's happening here as well, a little bit, because they're behind and it's not their core business yet. I think it makes sense for them to open source it. Yeah, I do think that direction is the direction of the winners. Even when you look at Kubernetes, it's winning, I would say, and like it's winning from AWS proprietary, container management systems. And I think Llama is winning as well. But that's to be seen. But I think, yeah, I'm really hopeful this is the direction where everything will be going.
Yeah, absolutely. So let's talk a little bit more about Nosana and how you guys are rewarding, I'll call them the providers or the GPU providers.
So how that works is you basically get paid every second you're doing work. So if your GPU is connected to the network, someone is going to run inference, then our smart contracts basically say, okay, we want, Llama 3.1, 8B. It fits really well on a 4090. So we're going to match you with a 4090 on the network. It will run on that specific GPU, and the owner of the GPU gets tokens. So if the job lasts for like 5 minutes, like 300 seconds, we pay per second. So for 300 times the reward you would get per second goes to that GPU owner. It also means that if there's no jobs on the market, you don't get paid. So it's not like a guaranteed income for GPU owners. We're seeing that there's a big demand for like the 4090s, 3090s, and the bigger cards like the A100s, H100s. Those are like the most popular cards. We have a lot of 4090s, for example. So that's sort of where you're guaranteed of getting a really stable, good return on investment on your GPU hardware. We also have a whole bunch of smaller cards, even laptop GPUs are on our network. There's a whole bunch of like smaller kind of cards out there because we do believe there is a lot of value and power in the small cards that with creativity and good engineering can be extracted, but they're just less popular right now in the industry. So how much you earn is really gonna depend on the demand from the market.
Yeah. And let's talk about some of the challenges you guys faced while building Nosana. I'm sure, anything in the decentralized land, especially in deep-end infrastructure is never easy because you're dealing with Harvard. So let's talk about some of the challenges you guys faced and how you worked to overcome them.
Yeah, of course. There's plenty of challenges. I think deep-end is, you're working with a handicap because you have all these, like from a technical perspective, you're like one leg down from what people can build in a centralized way. I think even in the deep inside, there's quite a few projects out there that are building semi-decentralized or half-centralized systems where payments are done in tokens, but there's still just a server sort of doing all the calculation and connections. And the more decentralized you get as a network, I think the harder it is, and the more challenges you face. There's too many examples, but maybe one people can relate to a bit is as Nosana is taking the path of we're doing it really decentralized. So we're doing a lot of logic on chain. Anyone can come in, or code is open source. So basically, we're allowing anyone to build and even to make adjustments to the network in certain ways. But it means, for example, that when Solana goes down or when it has like a big congestion issue, which we've seen in the last few months happen a few times, no one can order GPU power on the network. So that's something that's just very that makes us very unstable at times because when there's the congestion makes transactions very expensive. Using the network is very expensive. These kind of instabilities we have to work with. Then there is all these things around RPC providers that have to be like Solana has a really high throughput blockchain, but it means that getting a stable, good RPC node, which is your blockchain gateway that you can use to talk with the blockchain, those are quite expensive and often hard to find. We have some issues as well with storage, as like we don't use centralized storage or like we're trying to put all our like where we store not the models themselves, but the outputs from inferences and also like benchmarks and things around inferences that the network needs to know about. That's also a lot of data coming out of there. And we're storing this on IPFS, but we're noticing there are some issues there where IPFS itself isn't that performant or like it's often quite slow to propagate data in our network. So on the storage side, we're also working and trying to solve issues in how do we get data available to our network at all times. There's just too many, and mainly most issues are technical that I'm naming now. One of them is that models are big. I think like a Llama 70B is maybe quickly like a couple. Don't know the exact number, but maybe 30 gigabytes or something isn't where if you have to download 30 gigabytes of data to a computer at someone's home, that's an issue by itself. So we need to make bandwidth tractable and make sure people are pre-caching the right files. And there's many issues around the technical side for sure.
Yeah, absolutely. And can you talk a little bit about how you guys are, maybe different than some of the other existing, like we'll call them DeepIn, like cloud computing softwares, like Akash Network or any of the other ones in this similar space?
Good question. So there's quite a few players now, and there's more and more people coming into the space, like projects coming into the space with similar solutions. It makes sense. I think it's great because there's just such a big demand and shortage in the industry that GPU hardware needs a solution like this. And it's a massive industry. If you look at the market and how fragmented the market is and different types of cards, different types of clients, there's these university and experimental clients. There's a lot of big corporations that are now doing it's a really fragmented market, and people are still mainly using cloud providers for their GPUs because even with this shortage, it's a big hurdle for companies to embrace Web3 technology, to start using something completely new that's not that reliable yet, as we don't have that track record of uptime over X amount of years. And so I think it's good there's a lot of players coming into the space, and I especially like it when GPU providers are focusing on a really niche element of the market where they focus on and try to attract clientele and try to make companies use like Web2 companies use their GPUs for real. I think that's also where the collaborative spirit comes from. I think multiple of us need to start getting real clients on board and running real inferences on our networks. To make like the difference that in 10 years from now we can it becomes sort of the default to use DeepIn networks. That's where we need to go. And so, but to get a bit more specific, I would say a lot of networks are slightly different. I like Akash a lot. They have a way more ambitious, I would say, like a more broad scoping, and they've been around for a long time. So very cool project. But they are, I think, posed more to become like a super cloud, doing a lot of cloud computing and like sort of AWS types of features also there. Nosana is really focused on AI inference and specifically AI inference that fits on GPUs from consumers. That's sort of the area we focus on. We don't really do training, for example. That's a really big part of AI compute is around training. But we don't do it because it requires all kinds of things that make it more convenient to use data centers instead of consumer GPUs. So every one of us has, I think, their own upsides and downsides. And I do really believe that if we work together and normalize using DeepIn networks for Web2 companies, that's the way to win this. So the competition so far, I think, is a positive thing that's happening here.
Absolutely. Let's talk about some of the partnerships or collaborations you guys have, formed to advance the network or, grow.
We have quite a few partnerships released recently. I think over the last 2 months, we've announced around 6 or 7 partnerships with Web3 projects that are running AI. There's a big demand from these companies. Few of them are into gaming, so they want to run like Aurora is maybe rings a bell. We're working with them to make their AI agents more intelligent and put LLMs behind them. There's a few projects that are into creating Hugging Face type platforms where they also want to have GPU providers able to run the models. So that's something we're partnered with a few companies in that sector as well. So there's a lot of fun and really cool projects that are in need of GPUs that we work with. And on the other side, we're partnered with a few companies that are able to provide GPUs. As we've noticed from clients we've talked with and the progress so far, that there are really legit use cases where we can really benefit from having some sort of enterprise-grade GPU infrastructure available, or even just a larger GPU network available in running certain workloads. So we recently partnered with Picnic. They're a GPU provider. Traditionally, they did mainly Filecoin as their network, but now they have a lot of high-quality infrastructure. So we're able to run enterprise-grade workloads on their GPUs in the cases where we need them, which has proven really useful. We're also partnered with Render, for example. They're also, of course, I think very well known. But they have a lot of GPUs that are mainly used for rendering of graphics, and they have a significant overcapacity. So we're allowing people with that want to run AI jobs on those specific types of GPUs to basically go through Nosana onto the render network. That also expands our capacity a lot. So we have a lot of different partnerships going on with different projects, but these were just a few highlights.
Nice. And let's talk about any upcoming milestones that people can look forward to from Nosana, and then finally where people can learn about you guys more online.
Upcoming milestones are, we've been working really hard now on we call it test grid, but it's the current version of our network. And this means that we only allow companies access to the network like in small, like we onboard them manually, and we make sure that we have a good fit for them, and we sort of help them pick the right GPU markets and make sure everything works well. We're almost to a point where we can allow anyone to join the network. So that's sort of the big release that's going to come up at some point, is that we can really have anyone download our CLI tool and run workloads. So we don't have a date on it yet, but we're getting closer and closer after we're seeing great results from our testing environment now. But yeah, for people that want to stay involved, that want to be up to date, if you have GPUs, you can always register on our waiting list, and we are onboarding quite big batches of GPUs frequently as the demand grows. So the best way to reach out is go into our Discord. Like that's it's very active. It's where most people are, and follow us on Twitter for updates.
Awesome. So everyone, go join the Discord, go follow them for updates, go check out the website, and I'll put all the links in the description. Jesse, thank you so much for coming on here, and to everyone, let's get back to building the future of Web3.
Thank you, Jax.